Hello, this is Skylar, and you are watching RobotC for Mindstorms. Yep. Today, we are doing a smart line follower, as was requested by a watcher. So, thank you for your question, and yeah. So, very quickly, once again, the music is by Discord. You can check out his stuff. Well, you know this, guys. Yeah, it's great stuff. I like to listen to it. There's where to find it. So yeah, let's get started. So yep, new file. This is a robot version. This is the 3 build of RobotC because of what I said before, but it's not really any different except it puts that there for you. So I'm gonna need task name. I'm gonna go ahead and save this file so that it will compile, because it won't compile unless you save it. Just overwrite that. So what we're doing is we're making we're going to program a robot so that it follows a line, and when it's done following the line, it stops. And only using one light sensor. I mean, we could do this with other sensors, if we had other light sensors on it, or if we had an ultrasonic sensor and maybe a wall in front of us or something. We're going to do this with one light sensor, and not using the rotation sensors. And so, that's what we're doing today. And the theory of what we're doing is pretty simple. The robot, it takes time to go from here to the light sensor finding the line, and then it takes time to get back to the absence of the line, and then it takes time to get back to the line. And we can measure that time, and if that time is, if the time that it takes us to find the line is a big number, or if we're trying to find the line and the time has exceeded this number, then we can safely assume the line's not there. Or at least, yeah. So like right here, it might take us maybe 20, 30, I mean, let's just say 100 milliseconds to go from this position to this position. But when we're here, we're trying to find the black, it's going to take us seconds to find the black line. And so at 1 second, or whatever our limit's going to be, the robot is just going to say, okay, there must not be a line there, and we'll end the program. Now, the one part that the one limitation that I'm seeing right now, as far as this program goes, like, it's not, you can't just use this program for everything and solve all your problems at once. There will be some limitations, like what about that? That will be hard, because if our limits maybe gives up, like if our robot gives up here instead of going and finding that this is a corner, then you'll have to tweak this. But this is what we got right now, and I'll run the program and you can take it and run with it. So we've got task main, and right now I'm just going to build a line follower, and we'll fix it later. And so first thing, go to robot and motor and sensor setup. We're going to set up the light sensor so that use light sensor, and we want reflected light, because basically for the light sensor we want it to send out light and have it bounce back, and depending on the color of the object it's bouncing light off of, and I suppose the shininess of it, the reflectivity, we'll get different readings from white and black. And I'm just going to call this LGT. And bam, configures it, and it lets you know about that. Alright, so we need a threshold, because I'm going to do this the easy, quick way, and the threshold is basically that number. If the light reading is above that number, then we know we're on the white, and if it's below that number, we know we're on the black. And so we can go on here, turn the robot on, and you can go to view. Let me see if I can focus this a little bit better. Here we go. And you can go all the way to light sensor and don't do the black one. Do the, whoop. I said don't do it. That one. Do that one, because that one's reflected light when it shows stuff going out of the light bulb. And mine's on port 4, and so it gives a reading. So I'm going to take reading here, and I guess the camera can't really see it. It says 52, so that's white. And the black is 32. And so we want a number between 52 and 32. I'm going to pick 45. and that's just because I've already tested this program, and that's what worked before, and so I'm going to use that, but we can tweak that later if we need to. So here, I'm going to say int light threshold equals 45. Once again, saying, hey, there is a number, call it light threshold, and its initial value is going to be 45. And this is an int, which means it's a positive or negative whole number, from negative 35,000 whatever to 35,000. That's the limit. That's the range of values this thing can hold. So this is good. And alright, so let's get into task main. We want this to be following indefinitely, so I'm going to use a while loop, and I'm going to say while true, because that's short for while true equals true. So while true, and give myself a whole bunch of room in here. In here, I'm going to say if sensor value, and then LGT is greater than or equal to light threshold. So if the reading that we're getting right at this moment is bigger than light threshold, meaning it's, you know, or it's the same, 45 or above, then we have to be on the white. So we are on white. And then I'm going to put else, and basically if this is not the case, then the number must be below light threshold on black. And then I'll put some stuff in there later, but just thinking ahead, in while loops, I always want to put some kind of a wait, because if you don't, then things will kind of be weird, and you'll I mean, it's just good practice, and I've talked about that before. Yes. Alright, so there's that. Now let's put some stuff in here. We want to control some motors to make the robot turn one way or turn the other way. And not just turn, but actually go in that direction. And so an easy way to do that is just power one motor. So I'm going to say motor A equals 60. And I could do 100 here, but when the motors are going slower, I'm going to have slightly better results, because they're just, when you're going fast, it's hard to stop. And yeah, you get the idea. Motor C equals 0. And I want to make sure I put this line in there, but I mean, it looks kind of obvious. Well, obviously motor C is to stop. But if we're switching back between A getting power and C getting power, I want to make sure that C doesn't have power here. And so, yeah. It's a little bit redundant, but it's for a good cause. On the other side, oh, motor, key doesn't work. Alright. And on the other side, we want it to be the opposite. So, that is the basic line follower. Let's download it and make sure that it works. Because if this doesn't work, then the rest of our program has no chance of working. So, let's see. Plug in the robot. And download. And go back to here. And I'll see if... okay. And I'll take this other piece of tape off. Not the whole thing, just the one. Okay, I got that. My files, software files, and we'll run this guy. Oh, didn't start on the right side of the line. Okay. So, it followed it, but now we need it to stop before it, you know, keeps on going. So, that's an easy line follower. Yeah, I know it's disconnected. Okay, so now we need to modify this program so it includes a timer. And basically the timer is going to count up, and once it reaches the limit of that we decide, once that timer has gone beyond that, then it'll say, okay, we're giving up. We're just going to stop the program because there's no line here. But if it reaches the line, if it changes, if it either goes from no line to a line or line to no line, then we're going to reset that timer and count up again. And so what we're going to do is we need to declare some stuff. We're going to do int time limit, and that's going to be after this point it gives up. Like, you ever went to a web page and you tried to go there and it said the request timed out? Something like that. Basically, if we spend more than 250, that's going to be in milliseconds. So that would be a quarter of a second. If we spend more than a quarter of a second looking for the line and we haven't found it yet, give up. And then we're going to do int current time, and that's going to be, you know, the value of our actual time right now. Like, it's counting up. This is going to be the variable that holds the number that gets bigger and bigger and bigger. And if it's bigger than 250, then we're going to end the program. And then we're going to do something called bool last state. And basically, when I first did this, I wanted to just count up when we were searching for the line, but I got slightly better results when I was looking for change either way. And so with this is going to say what was our last thing that we did, and I'll explain later how that works. In here, this is when we're detecting white. We need to check if the last thing we detected was black. Because if the last thing we detected was black, we need to reset the current time. But if we were detecting white before, then we shouldn't reset time. I mean, if we didn't reset, if we resetted time every time this was every time in here, then we'd never get anywhere. I mean, the counter would not go up. So I'm gonna say if last state, and once again, when you have a bool in here, like true or last state, and that's just by itself, it assumes it's shorthand for, well, if last state equals true. That's just programmer's shorthand. So I'm gonna write a little bit of structure here. So if last state is true, then I'm gonna say current time equals 1 and last state equals false. Basically what we're saying is, if last state is indicating that we weren't on this before, if last state, like, last state is going to be true, is going to be set to true when we're on black. And so it's saying if the last state was black, then we're going to set the current time, we're going to reset it so that it's 1, and the last state is now going to be indicating that we're on white. Else, if we're not undergoing a change from black to white, we're just going to say current time plus plus, and that's short for current time equals current time plus 1, but since that is long and kind of boring, we're going to say current time plus plus. And if you wanted to add it by 2, you could do plus equals 2, or plus equals 3, but plus plus is just add 1. Alright, so that's that part, and we want to keep this the same because we want the motors to do stuff. Now to on black. On black, we're doing if not last state. Basically, not in front of a bool inverts it, and so that is short for just this, you know, not last state is short for equals false. But this is a little bit snappier and it looks cool. And put the else in there. So in this one, we need to change last state to what it's going to indicate on black, meaning true. Last state equals true. And we're going to reset the current time. Current time equals 1. And in the else, we're just going to say current time plus plus. So basically, this part right here and this part right here, they are sort of reciprocals of each other. Basically, this says if the last state was on black, then reset the time and set the state to on white. And if this isn't the case, if we were on white before, meaning going into here, then we're just going to add 1 to our timer. And basically the same thing on black. This says if the last state was white, then reset the time and change the state to black. Otherwise, if we were on black before, then just add 1 to the time. Okay? Alright, so this isn't quite done because this is all just in a loop. Like, we're not really doing anything. We're not checking current time against time limit, and so we need to add that part. So I'm going to add it right here, and basically it's if current time is greater than time limit, meaning the value of time limit, or the value of current time exceeded time limit, then we need to get out of this while loop, because while we're in it, we're just gonna, yeah. So there's a nice nifty little command, should know by now, it's called break. And that will get out of that'll exit the most recent loop. Like, if I had a while loop inside of a while loop inside of a while loop, and I put a break inside of that one, it would only break out of that while loop that was inside all the other ones. It wouldn't break out of all of them, just the closest one. And but before I break, because various things, I've noticed that, like, this program, if you download it right now, it'd run all right. But when you tell the NXT to end the program, or it ends the program by reaching the last piece of code, it doesn't stop the motors as quickly as if you write it inside as actual commands. They'll stop the motors, but it'll be a little bit later, and we want this to be as close as possible, and so that's why I put those in there. So, I'll compile it. Oh, I got an error. Undefined variable time limit. I've got time limit up. Oh, timid limit. There we go. Get rid of the extra T. Okay, so now download it. And 5. Now we'll switch back to lights, camera, and action. Okay, so, and I'll make this big. So, run the program, and it gave up and said, hey, there's no line here. And it stops. But the one thing that we're kind of having a problem is, I mean, I don't know if it is nice for you, but I don't really like that the robot is now out of alignment with the line. Ha, good pun, right? And so, let's make it correct so it gets back to at least the general direction of the line, so it's not just like that when it's done. So it's more like that. So, yeah, let's do that. So, it's a little bit nifty that we have this variable called current time, and so that will be some big number, more than 250. Well, technically, hopefully, it'll be 251. That is our hope. And so what we're going to do now is we're going to count backwards, count down from whatever current time is, down to 0, and during that countdown, we're going to power the motors in the opposite direction that they were in before, and that will correct. So right here, basically, this breaks out of this while loop, and this opening, and this is this closing, so which means when that triggers, program jumps down to here. Now, we're going to do another while loop, while current time is greater than 0. And inside here, quiz. What should come here right here? What is one definite thing that needs to happen in here? Well, current time minus minus. We need to change current time so that it gets smaller, otherwise we'll never get out of this loop. And we also need wait 1 msec, because otherwise, if we don't put this in here, this will count down as fast as it possibly can, which is more than it'll do it faster than by milliseconds. So we need to have this right here. Like, if you want to change this to whatever, if you wanted to only monitor it every 10 milliseconds, that's cool. But remember, change that to there too, because we want the same time it takes to go off the line as it takes to go back on the line. So keep that there. And here, just very sort of simple part, say if last state, meaning like, this is basically saying if we were going on the black, then make the motors go one way. We got motor A equals 60, motor C equals 0. Basically, this is telling us what was the last thing we were doing when we were following the line, and do the opposite of that when we're going backward, you know, because we're trying to find the line, we're trying to correct what we were doing before. And else, we want motor A equals 0, motor C equals 60. My bad. And again, right after here, instead of having the NXT take its sweet time stopping the motors, we'll do it. We'll tell it to. Alright, so this part right here is our compensation, and let's test it. Select the robot in, and download it. Okay. So there we go. A bit more compensation, right? And we can get this a bit more accurate if we had more sensors, or if we use the rotation sensors. We could, we could do that instead. We could, instead of using time, we could calculate how many rotations have the, how many degrees have the wheels turned, and base our, should we give up on that instead. But this was simple enough, and I just want to get it out there. A little bit harder to do the tutorials now that I've got a job and I go to community college, but hey, this is the stuff that I mean, this is what I like doing. So yeah, hope you liked it. Thank you to the person who sent this in, and yeah, if you have any more specific tutorials you want me to do, be happy to take a look at them. And yeah, thank you, and have a good weekend or whatever.